Hey guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 1351. Count negative numbers in a sorted matrix. Given a m into n matrix grid which is sorted in non-increasing order. So this is the most important word. Both row wise and column wise. Return the number of negative numbers in a grid. Okay. So let's see this example. See here. So this is the 2 into 2 matrix. Okay. Now we want to count how many negative numbers are there in this matrix. Okay. So see here, this is the first negative number and this is the second negative number and these are the next two negative number. So totally there are 4 and then here there are 4. So I can say there are totally 8 negative numbers. Fine. And then see here, there is no negative number in this array. Right. So we just written 0. So this is what the problem statement. It is so simple to understand. Now how to do this? The brute force is the easiest approach that comes into my mind is just iterate to this all elements. Just iterate to this all elements, then check whether it is less than target. Sorry, it is less than 0. That means it is negative number. So just traverse, and then whether it is a negative number. How to check whether it is a negative number? Just check whether it is less than 0. If it is less than 0, it obviously opposite. It is a negative number. Okay. If it is negative number, then just add it to the result. Just add it to the result. Okay. So this is the simple approach. So what is the time complexity? I can say the time complexity is O of n into m, number of rows into number of columns, and what is space? It is O of 1, right? So this is what all about the brute force approach. Okay. Now how to optimize it? Okay, this will think in different way. The first clue I have is it is a sorted order. It is in a sorted order. Each and every row is in a sorted order. Okay, in non-decreasing order, right? In what? In decreasing order, right? In decreasing order. Okay, okay, fine. Now let's take an example: 4, 3, 2, minus 1, and then 1, 1, minus 1, minus 2. Let's take this two examples. Now, ordinarily, if we want to find how many negative numbers here, how can we do using a binary search approach? Because it is in sorted order, right? So we can use binary search approach. Now, how can we do in a binary search approach? The simple thing that comes into my mind is I want to find the least in this. The least in this, that is a starting point of the negative value. The starting point of negative value, and from that starting point to the end of the array, obviously it is going to be a negative value, right? Take for example, here there's only one negative value. So the starting is 0, 1, 2, 3. So the starting index is 3. What is the length? It is 4. The length of the array size is 4. So 4 minus 3 is equal to 1. So I got it. I got it. Okay. Now here the first occurrence of negative value is at second index, right? Is at second index, right? So 4 minus 2, which is equal to 2. So I got output. Now can you visualize it, right? So how can we do this? Okay, fine. Now we can go for a method. See here. Let me take a simple example. Now take for example, it is a lower limit and this is the upper limit. Now what is my mid? I can say my mid is this point 0, 1, 2, 3. Yes, now my mid is 3. Whether 3 is positive or negative, 3 is positive. 3 is positive. So if I want the first occurrence of the negative, do I move towards left or towards right? I can say I want to move towards right. Why I want to move towards right? So that I can get, I may or may not, but I may get a negative value when I am going towards right side, right? So that I'm just moving towards right side. Okay. So to move towards right side, I just shift this low pointer here, mid plus 1. Okay. So what is my first observation? My first observation is if mid value is positive, then I have to move towards right side. So L is equal to mid plus 1. So this is my first observation. Again, take for example another array like 1, minus 1, and then minus 2. Now just say Let me also have another element, like let me write another example. 1 minus 1 minus 2 minus 3 minus 4. Okay, now just say 0 1 2 3 4. Okay, integers. Now what is my midpoint? This is my midpoint. Here is my low pointer and here is my high pointer, right? So this is my midpoint. Now whether my midpoint is negative or positive, it is negative. So the mid value is what? Negative. Then what should I do? What should I do? I should move towards right or I should move towards left. If I move towards right, if I move towards right, obviously there will be a negative value, but this is the first occurrence of the negative value till now. Till now, it is the first occurrence. If I move towards right, it may be a second occurrence or third occurrence, maybe. But if I move towards left side, there may be a negative value, which is the first occurring negative value. So I want to move towards left side. Okay, but this can be my part of my answer if there is no negative value this side in left side. So this can be my part of my answer, right? So I will take that as my part of my answer and then I will move towards left side. So my u will come here, right? Again I will do I will take the mid pointer. Now it is 1, so it is positive, so I want to move my low to mid plus 1. Now this is my mid. Now the mid is where it is at negative value, so I will update that mid into my result. Then u is equal to mid minus 1, so my u will become here. Yes. Now u is here and L is here, so u is less than L, so I will terminate this. Yes. So we have got the two relations. What are they? If mid value is positive, then I have to do L is equal to mid plus 1. If mid value is negative, I have to result is equal to mid, then u is equal to mid minus 1. Yes. So let's write that in code. See here. Yes. The brute force approach. Okay. See this. I just traversed from each and every elements. Then I'm checking whether that element is less than 0. If it is less than 0, I just count it. I just count it. Okay. Else I will break. Simple. Okay. And then return C. Okay. I'm just moving from back to front like this. I'm just moving this back to front. Minus 1. Yes. No. 2. No. Then I will break. Okay. No. Minus 1. Yes, I will take into account. Now 1 break. Now minus 2 take in count. Minus 1 take in count. 1 break. Now minus 3 take in count. Minus 2 take in count. Minus 1 take in count. Minus 1 take in count. That's all. So this is what the first program does. This first approach does. Okay, let me comment this and then let me submit this code. Yes, it is unsuccessfully. And then I have forgot to say an important point in this binary search approach. Just see here. We have got the first occurrence of negative value. But how can we calculate the count of the negative values? It's simple, right? Just the length minus the first occurrence. I have told you, right, in the start itself. Here, wait, where? Here I have told you, right? 4 minus 3 and 4 minus 2, right? So the length minus the first occurrence of the element, right? The negative element, right? So that's what we are going to do in the binary search approach. Just see here. Let me come on this. Yes. Now I'm just traversing each and every row. Now count plus is equal to search of row. The search of row will be doing my binary search approach. Okay. Now just see here. Start comma end is equal to 0 comma len of row minus 1. Now answer is equal to len of row. Why I am storing answer as len of row? Because if there is no negative value, then obviously the the default value of the answers would be what? It is len of row, right? Now while start is less than or equal to end, mid is equal to, just I am calculating the midpoint. Then if row of mid is less than 0, that is it is negative value, then it should be my part of my answer. It may be my part of my answer, but still we may have a better answer in left side. So I'm just moving the end to mid minus 1. Now else start is equal to mid plus 1. I'm just moving my start pointer to mid plus 1. Then I'm returning len of row minus ans. I have told you, right? 4 minus 2, 4 minus 3. Yes. Now let me submit it. Yes, it is submitted successfully. So this is what all about the binary search approach. And then the important note is what is the time complexity of this approach. I can say the time complexity of this binary search approach is, just see, we are just traversing each and every row. Okay, let me take. So we are traversing each and every row. So number of rows into log of number of columns. Why log of number of columns? I am doing a binary search approach. So this is my time complexity. S. So this is my time complexity. And what is the space complexity? It's work one, because we haven't used any auxiliary space. Okay. So this is what about the binary search approach. Thank you.